Here's a quick lesson on writing an equation for the perpendicular bisector. Now, you might remember a previous lesson on constructions, on how to construct the perpendicular bisector. And constructing a perpendicular bisector is really easy. All you got to do is put the compass on one of the points, making sure you're open more than halfway to the other point. So we have two congruent circles that intersect at two different points, like so. Then I can get rid of the compass at this point, and I'm going to highlight the 2 points of intersection. One was right there, and one was right there. And basically, at this point, all we really need to do is put our straight edge down on those 2 points and draw the line. I'm going to use the smartboard to extend those lines, and there you go. That's the construction of a perpendicular bisector, a line which is exactly in between those 2 points and perpendicular to the imaginary line that would be connecting those 2 points. However, the writing of the equation is a little bit more complicated. So let's keep this image here of the perpendicular bisector and go through the 4 important steps. Okay, let's take a look at these 2 points on a set of axes. Now you can see that point A was actually -6, 4. And the point B was 2, -8. Now, one of the problems with writing the equation for a perpendicular bisector is that neither of the 2 original points are on the line of the equation you need to write. However, the point that is exactly in the middle of those 2 points, the midpoint, should be on that line. So step 1 is finding the midpoint. Now, we already know that the equation or the formula for writing a midpoint is just adding your x's and dividing by 2 and adding your y's and dividing by 2. So that's pretty simple. So I'm going to open up parentheses here, and I'm going to take -6 plus 2 and divide it by 2. And then I'm going to take 4 and add it to a -8 and divide it by 2. When I add -6 plus 2, I get -4 divided by 2, which gives me -2. And 4 plus -8 is also -4 divided by 2 is -2. -2, -2 should be the midpoint of those 2 points and on the line in which we need to write the equation for. So I'm going to put that point right there, and I could see, yes, it is on the line. If I put an imaginary dotted line from A to B, I could see that it also does look like the midpoint. Okay, step 2. Now, we need to know the slope of the perpendicular bisecting line. However, without the slope of the original imaginary line that connects A to B, we can't find that slope. So step 2 is finding the slope of AB. Well, we know the slope formula all the way from algebra, which is we use m to represent slope, lowercase m, and it's the difference of our y's, y2 minus y1, over the difference of our x's, x2 minus x1. So the slope of AB should be 4 minus -8 over -6 minus 2, which should be equal to 4 minus -8 should be positive 12 over -6 minus 2, which is -8. Now, some of you still have problems simplifying fractions, so if you, I recommend that when you're doing slope and you have your fraction is to bring up your calculator and just put the fraction in as division, 12 divided by -8. Then you can hit the math button and enter button twice, and it will simplify your slope to -3/2. Now I can go back and I could see that that's absolutely correct, right? I'm going down 3 across 2. Down 3 across 2. Yes, that is the slope of AB. Now, once we have the slope of AB, it's a very simple process to find the perpendicular slope, because we've already learned that perpendicular slope means, takes us to step 3, this will appear, is the negative reciprocal, taking the negative reciprocal of the original 2 points, which is as easy as switching the sign and turning the fraction upside down. So I could see that the slope of AB is a negative slope. So the slope of my new line, I'm going to put a little upside down T to say perpendicular slope, will be positive. And if I turn 3/2 upside down, I get a positive 2/3, or positive 2/3. I now have everything I need to finish this problem. I have the midpoint, -2, -2. I have my perpendicular slope of positive 2/3, which brings us to the final step, step 4, which is utilizing steps 1, the midpoint, and steps 3, the negative reciprocal slope, to write the equation in point-slope form, which we've already learned how to do. The point-slope form is y minus y1 is equal to m times x minus x1. Or really, all we need to do is substitute a value of x, a value of y, and our slope. So if we go back to our midpoint, we can see that our x1 and our y1 are both going to be -2. And we can see that our negative reciprocal slope is going to be a positive 2/3. So let's start substituting. So we have y minus, open up a parentheses, -2 should be equal to positive 2/3 x minus also -2. Now we all know that we're going to do one more very important thing here, which is get rid of these parentheses and these negative negatives. So our final answer, the perpendicular bisector of A and B, should be y plus 2 equals 2/3 x plus